We were talking about covalent bond, and we stopped where we talked about Lewis structure, where octet of electrons are shown on the Lewis structure of the covalent molecule. So I'm going to start from there. Now we talked about covalent bonds are formed when electrons are shared between two atoms. A bond is formed. To make a bond, two atoms use their valence shell electrons, and eventually idea is to get the octet of electron. For example, hydrogen make one covalent bond sharing one electron on each hydrogen, and make a covalent bond. Hydrogen get the helium structure. Hydrogen have two electron pairs right now shared by E. Therefore, hydrogen gets the helium configuration. So we talked about how the water forms a Lewis structure shown in here, one on the right side with octet of electrons on the oxygen atom and duet of electron on the hydrogen atom. Therefore, hydrogen achieves helium electronic configuration, oxygen gets the neon electronic configuration. Same goes for ammonia. Ammonia is formed by nitrogen and hydrogen element. Three hydrogen react with one nitrogen atom, make a NH3 molecule, which we call ammonia. Right, ammonia. The central atom has octet of electron, hydrogen have duet of electron, so they make stable electronic, noble gas electronic configuration. We went over this also. CH4, four hydrogen atoms with one electron on each, shares electrons with carbon, which has four electrons. Eventually, in the Lewis structure, you get four bonding electron pairs. Electron pairs found on the one atom without being shared is called non-bonding electron pair, non-bonding or lone pair of electrons. Now, to draw a Lewis structure, what you have to do is get the formula of the compound. From the formula of the compound, count all the valence electrons are on all atoms, valence electrons on each atom. Then determine the connectivity. Connect the middle atom to the terminal atom with a covalent bonding. So bonding electron pairs are shown by a line. We draw a line for the bonding. Non-bonding electron pairs, sometimes with a dot. For example, water. Sometimes we show with a dot, non-bonding electron pair. Or line that stays on top of it, where the bonding electron, non-bonding electron pair. So these are the ways to draw the Lewis structures. A molecule, after forming bonding electron pairs, still didn't have an octet of electron, so they can share lone pairs of electrons to make double bond, triple bond. Double bond is where the two electron pairs are shared between atoms, and triple is when three electron pairs are shared between atoms. So on Lewis structures, we see non-bonding electrons, single covalent bonds with a one line or double line for the double bond, triple line for the triple bond. We gone over this last time. For this molecule, ammonia, what is the correct Lewis structure for this atom? This one is not correct because if you look around the nitrogen atom, it has 1 electron pair, 3 electron pairs, that means 6 electron pairs. And on top of that, there are 5 dots. It shows 11 electron pairs, 5 plus 6. Therefore, it's not the correct one. This one, nitrogen, have only 6 valence electrons. Nitrogen has in H3 5 plus 3, 8 electron pairs. Nitrogen is 5A group, 5 electron pairs, 5 electrons. Hydrogen is 1A. Altogether they make 8. Therefore, total number of electrons around here is 3 pairs, 1 non-pair, 8. So correct answer is C. In the Lewis structure, you have to have an octet duet for hydrogen, octet for other atoms except hydrogen. Therefore, correct answer is C. For carbon dioxide, if you write the carbon dioxide, central atom is oxygen because it makes most bond. The connectivity is decided by the central atom. Carbon dioxide has 4 electron pairs, 12. 6 times 2 is 12. Altogether it has 16 electron pairs. 16 electrons. It has 8 electron pairs. When you put the carbon, now I use already 8 electron pairs used. 3 here, 3 here, 3 here, 3 here, 2 here, 8 electron pairs. It shares electrons to make double bonds like this. Now carbon has 8 electrons, oxygen has 8 electrons. What is the correct Lewis structure? Lewis structure is this one. There's a line with 8 electrons. This is not carbon dioxide. This is carbon monoxide. That structure is wrong. It has 4 plus 4 electron pairs on the double bonds and 7 electron pairs. It has to have 8 electron pairs. So that B is sulfur dioxide. So the Lewis structure correct one for carbon dioxide is A. Water we already do Lewis structure. Central atom is oxygen. There are 8 electron pairs. 2 plus 6 is 8 electrons. Electrons, 4 pairs. 4 pairs. So it has 4 pairs here. Therefore, correct structure is not this one. This one has only 2 electron pairs, 3 electron pairs, 4 electron pairs. That's wrong connectivity. C is the correct answer. HCl has, hydrogen has 1 electron, chlorine has 7. Therefore, total is 8 divided by 2 is 4 electron pairs. So 1 is the correct structure with 4 electron pairs. This one has more than, A has more than 4 electron pairs. This one has only 1 electron pair. The last one has correct bonding. The C is not correct because hydrogen cannot have double bonds, only a single bond. Therefore, correct answer is D. Now we go on over this. Water has 8 electron pairs in the valence shells of all the hydrogen and oxygen atoms. So structure is central atom is oxygen, then you connect the terminal atoms and fill octet duet to hydrogen and hydrogen duet, oxygen octet, you get the structure. Ammonia also has 8 valence electrons coming from nitrogen and hydrogen. Then you have 8 electron pairs, 4 electron pairs, total of 8 electrons divided by 2 pairs. Since we write bonds with the arrow is a pair, so normally we go ahead and count the pairs. Methane has 8 electrons from 4 carbon one each from hydrogen, that's 8 total, 4 electron pairs. Now we have 4 bonding electron pairs on the methane molecule. HCl, we already done that, 8 electron pairs. The octet is around the chlorine, hydrogen has a duet. Now total electron pairs are 4, 8 divided by 2. That's how you get the Lewis structure. Now when you have methane, this molecule is called ethylene. The connectivity is carbon is bonded to each other. Connectivity is carbon bonded to each other. The total number of electrons are 12. 6 times 2 is, carbon has 4. 4 times 2 is 8. 8 plus 4 is 12. You get the 12. There are, after you make the connectivity, connect carbon and terminal atoms, you have one more electron pair. This is 12, 6 electron pair. This already uses 5, 2 each. So you put a double bond to get the carbon octet. So that's how you get, this is acetylene. It has a triple bond. Total number of electrons is 2, 1 from each hydrogen, 4 from each carbon, total of 10 electrons. 10 electron is 5 pairs. Therefore, 1 here, 1 here, 3 here. The total number of valence electrons are counted. Formaldehyde also has the carbon as the central atom. Total of, if you count the carbon, 820, total number of 4 from carbon, 2 from hydrogen, 2 hydrogen atoms, 1 from oxygen atom, total becomes 12. 4 plus 2 plus 6 is 12. There are double bond here. Octet is for the oxygen atom. Octet 8 electron, 4 pairs around the carbon. Therefore, it's correct Lewis structure. Carbonic acid also has that Lewis structure. This is kind of complicated. We are not going into that kind of thing, but once you get the connectivity, carbon is in the middle, 2 oxygen are attached to carbon, 3 oxygen attached to carbon, and hydrogens are attached to 1 each on the OH. All the carbons, oxygens have octet, hydrogen has 12. Therefore, total number of 24 electrons or 12 pairs. So that's the correct Lewis structure for carbonic acid. Now let's answer some questions about Lewis structure. Which of the following molecular compound is same as covalent compound would have Lewis structure that contains 10 electrons. Now you have to count the electrons. How many electrons HCN has? How do you get that? HCN. Carbon, hydrogen has 1, carbon has 4, nitrogen has 5. So 10 electrons. So this should be the correct answer. Water has 8. Ammonia has 8. Carbon dioxide, we already calculated. It has 16. Carbon dioxide has 4 plus 12. Therefore, HCN is the one has 10 valence electrons. The dots, electron dots are going to be the valence electron in the Lewis structure. Now you have to know this on the side I wrote down. You look at the group where the hydrogen is, 1A, has 1 electron. Hydrogen is in the 1A. Carbon is in 4A. It has 4 valence electrons. That's how I get this number. Oxygen has 6 valence electrons, 6A. Remember, we've gone over this. Answer is A. NO2 Lewis structure. NO2 plus Lewis structure. Now you have to answer question about this. First you have to draw the Lewis structure. Nitrogen is central atom. Why? Nitrogen makes 5 bonds. Nitrogen makes 3 bonds. Covalent bond. Oxygen makes 2 bonds. Therefore, nitrogen is in the middle. You connect with the one line electron pair. So total number is 5 plus 12 from oxygen. When you have a plus charge, that means 1 electron is lost. When a group of atoms lose 1 electron, it becomes positive charge. The total number of electrons is going to be 11 plus 5, 60. There are going to be 8 electron pairs. So when you look at this nitrogen, how do you get the Lewis structure? You put octet to carbon, oxygen, terminal atom, connect with center. Now you already have 8. You see, you have 8, 4 here, 4 here. Now you cannot have more than 8 on the structure. We draw a double bond. So therefore 8 valence electrons, 1 single bond, 1 double bond, and 5 non-bonding electrons. 2 double bonds, no. 8 non-bonding electron pairs. This only 5 non-bonding electrons. 1 double bond, single bond, 12 non-bonding electrons. 12 non-bonding. 1, 2, 3, 4, 5. 10 8 non-bonding. I am counting here. This is only, that's 2 double bonds. That's the octet. Here, octet. I didn't draw the 2 double bonds. 2 double bonds. 8 non-bonding electrons. The answer is 8. Did you see how I got it? It was kind of tricky. How many non-bonding electron pairs in the Lewis structure? Carbon dioxide. I got the answer already. If you look at this structure, how many non-bonding electron pairs? There are 4 of them. 4 is 1, 2, 3, 4. Answer is B. I already drew the Lewis structure for carbon dioxide in the previous problem. Formaldehyde, Lewis structure, how many electrons must be shown in the Lewis structure? Formaldehyde. The number of dots that should be shown in the Lewis structure should be sum of the valence electrons. Therefore, this is 4, this is 2, 1 times 2, 12. 12. C is the correct answer. Ammonium ion. How many electrons must be shown in the Lewis dot structure? Ammonium ion has 8 electrons. How do I get 8 electrons? 5 plus 4. 1 times 4 is 4. 1 times 4 is 4. Minus 1. Why minus 1? When you have a charge, you add subtract. If it is a negative ion, you add 1 electron. So this is 8. Therefore, 4 pairs. So how many electrons must be shown in the C is the correct answer. Hydrogen cyanide. How many must be shown in the? We already did that. 10 electrons. Remember we did that for one of the problems. Should be C. Covalent compounds with multiple bonds. We already talked about carbon dioxide, ethylene, acetylene. How many bonds does carbon typically form? Carbon typically forms 4 bonds. How do you get that one from Lewis dot structure? Carbon has this grid dot structure. When you're making bonds, when you have four electrons are shared, they become single electron. Therefore, carbon forms four bonds. Answer is B. When you're making Lewis structure has a lone pair, but it gets excited to four four lone pairs of electrons, which could be shared. So therefore, answer is B. How many carbons carbon make? 4 bonds. How many bonds carbon make? 4 bonds. Nitrogen makes 3 bonds. Oxygen makes 2 bonds. Chlorine, halogen group make 1 bond. We look at ethylene. Ethylene has a structure of this. 1 double bond, 1 double bond. B is the correct answer. Acetylene has this structure, triple bond. Therefore, acetylene should have a triple bond. Correct answer is C. Which of the represent the best Lewis structure for acetylene? C2H2. Remember, Lewis structure is, we go know this, you count the C2H2, 8 from there, 2 from there, it's the 10 electron divided by 2, 5 pairs. So you connect the carbon first, then hydrogen has duet. These are now, you have to put 3 bonding electrons to get the octet. Now this has 8 electron pairs, 8 electron pairs. So best, which of the following represent the best Lewis structure for acetylene? A. Now there are exceptions. We have rules, we also have an exception. You notice that. Always our rules are not going to be followed by real stuff. We are only using models. Models have limitations. So this happens when you have more than octet of electrons, because group 3 onwards have d electrons, 3d. Therefore, it could be more than 8 electrons. For the first period, octet rule is, second period, octet rule is obeyed. First period is changed to duet. Helium is the noble gas in the first period. Octet rule is based on the idea maximum of 8 electrons. Period 3 elements, starting from sodium, magnesium, aluminum, silicon, phosphorus, sulfur. Period 3, 4, 5, 6, 7 have d orbitals. Therefore, you can have more than 8 electrons. So you have to accommodate for that d electron. This is phosphine. Just like ammonia, this has octet of, that's not an exception. But if you have phosphorus, group period 3 element, third period, if you look at the period, phosphorus has d electron, therefore it can have more than octet. This atom also have phosphorus atom because it's a period 3 element onwards, period 3 onwards, elements can have more than octet. Sulfur is also period, third period. Therefore, this has octet, that's okay, but this one has a 10 electron. This one has a 12 electron. Therefore, when you get to third period onward, elements can have more than octet of electrons. If you take NO, that is an exception to octet rule. NO. 5 plus 4, 9. You always have a hydrogen, 9 electrons. 1, 2, 3, 4, 5. 9 is 4.5. there's one electron. Therefore, when a Lewis structure have a lone pair of electrons, that is the exception. That's not a duet or octet. So, NO contains an unpaired electron. That is the correct statement. Therefore, it doesn't obey the octet rule. In a Lewis structure, atom can have more than 8 electrons associated. Which atom is this? Group. These are all group period say to carbon and fluorine is group 2. Period 2. Phosphorus is third period. Therefore, third period can have more than octet of electrons. In a Lewis structure, which of the following atoms can have more than 8 electrons associated with? Sulfur is the only third period, more than third period. You look for the third period, fourth period, fifth period. These are all second period. Therefore, sulfur is the correct answer. Now you begin to realize there are exceptions when you have one lone pair of electrons, more than octet of electrons, less than octet. This has, when you write beryllium hydride, Lewis structure is, this has only 4 electrons. Beryllium has 2 plus 2 is 4, divided by 2 is 2 electron pairs. Therefore, when you have 2 electron pairs, that is exception to have lower than octet of electron. Therefore, beryllium is the correct answer. B is BeH2. Now, there are 2 types of covalent bonds. One is called non-polar covalent bond. Other one is called polar covalent bond. Between 0.5 and 9, we talked about it. It's a polar covalent bond. Therefore, answer is C. We go now electronegativity. Non-polar covalent bond is less than 0.5. This is covalent bond, polar covalent bond. So answer is B. Non-polar covalent bond is less than 0.5. Between 0.5 and 0.9 is polar covalent bond. Therefore, answer is. Now we go over Lewis structures. Now we talk about exceptions, and we also talked about the polarity of covalent bonds. When the bonding electron pairs are shared between 2 atoms which have electronegativity difference, the covalent bond could be non-polar or polar, less than 0.5, non-polar, greater than, between 0.5 and 1.9, it's polar covalent bond. Now this is easy stuff now. To name a covalent compound is similar to ionic compound naming. We set the name of the ion and the anion, sodium chloride. Like that, we use the, if you have a covalent compound, we normally write the covalent compound is the least electronegative atom first. Carbon is the least electronegative atom. To name this compound, just like ionic compound, we say carbon dioxide. Now we are using prefixes. Remember, in ionic compound we can use prefixes. Now for ionic covalent compound we have to start using prefixes. We use prefixes. Di means 2, tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7. You have this one, carbon monoxide. If we have a first one, we don't say monocarbon dioxide. First one is 1, we just leave it as carbon. So this is carbon monoxide. Mono is 1. What would this be? Can you tell me what the name of this one? Least electronegative is sulfur dioxide. right? You had to use prefixes. Nitrogen oxide. We don't say nitrogen monoxide here. This has a common name called nitric oxide, has a same nitrogen oxide. Sulfur difluoride. Sulfur difluoride is SS2 sulfur. First name is, you don't say mono if this is one. Nitrogen dinitrogen, if it is 2 in the first least electronegative atom, then you have to say dinitrogen oxide. Example, for this one, nitrogen dioxide, dinitrogen tetroxide, nitrogen dioxide, dinitrogen tetroxide. Did you get the idea? Ionic compound name is different from covalent compound naming. Prefixes are used. The name of a binary covalent compound, which of the following is true? Element that has more atoms in the molecule is the name first. No. It's nothing to do with number of atoms. Not according to the alphabetical order. Second one is false. We name the less electronegative atom first. So first element we write name for covalent compound is the least electronegative atom. Which of the correct compound, chemical formula of the compound for N2O3, dinitrogen trioxide. That's the D. Now from the formula you should be able to get the name of the covalent compound. What is the name of SCl2? Can you tell me what the name of this one is? Sulfur. Sulfur is the least electronegative atom. We write first. No, sulfur dichloride. What is the name? Sulfur dichloride. Agree? D is the correct answer. What is the name for this one? Carbon 2 sulfur. Sulfur is called oxide, sulfide. Carbon disulfide. Carbon disulfide. A is the correct answer. Not A, because this has to be sulfide. D is the correct answer. Name of the dinitrogen pentoxide. Dinitrogen pentoxide is 2-nitrogen 5-oxide pentoxide. A is the correct answer. Did you see A is the correct answer? What is the formula of dinitrogen tetroxide? N2O4, right? 2 nitrogens, 4 oxide, N2O4. N2O4 is C. Now we done the basic stuff about covalent bonding. Now we are going to go into the idea about last 3 topics in the chapter 3. Last 3. It's about the resonance. Second topic is last 3 topics. Second topic of the 3 is bond angle, molecular shape of a covalent compound, and the polarity of the covalent molecule, third one. So we start with resonance now. Now, do you have any questions about covalent bond? We drew the Lewis structures, we drew the formulas, we got the names of covalent compounds using prefixes and the least electronegative atom written in the formula first. Those are the ideas. Now there's a problem here. This is the carbonate ion. When you get the Lewis structure of the carbonate ion, you put the electron, you get two structures. Can you tell me what is the difference between these two structures? Can you look at it? What is the difference between these two structures? The double bond is in a different carbon and oxygen bond. It's here, it's there. Therefore, there's a problem. You can write in third place also. Double bond. Now, this person, Linus Pauling, notice that three structures could be written for carbon dioxide with the same number of valence electrons, same bonding electrons, non-bonding electrons, same charge, but the double bond is distributed over the three bonds. Therefore, real properties of double bond is not found in one carbon atom. It's found in all carbon atoms. This is called resonance. Resonance is you have different properties, but real thing has everything from the contributing structures. The real molecule has double bonds, partial double bonds here, all around here. So this is a problem in organic chemistry. Many organic molecules show resonance. Covalent molecules can be best described by writing two or more Lewis structures. To describe the Lewis structure of certain compounds with double bonds, you had to write more than one Lewis structure. That's the resonance. The individual structures we write for molecules are called contributing structures. A double-headed arrow is shown for resonance. The real one, carbon dioxide, carbonate ion structure, bonding, is in between these two. There are three of them, three resonance structures. The double side of the arrow here indicate resonance, the distribution of a double bond around the molecule. You might think why I need to know about this. But when you look at molecules, for example, organic molecules, which is called benzene. There are three double bonds, but these three double bonds could be in between here too. Therefore, to describe the molecule, you have to draw two Lewis structures. So when you're doing organic chemistry later, you need this idea. Resonance hybrids are blending of contributing structures to real structure. For example, how you move a double bond around the double bond from here to here. Double bond could be made here, it becomes a single bond. You use curved arrows. Carbon dioxide has three structures. How you move from there? This lone pair goes and make a double bond here, and this becomes a single bond. So curved arrows are used to get the contributing structures. Sulfur trioxide also shows this. Now, this is not a big deal. We only saying that in drawing Lewis structures, sometimes we need to write more than one Lewis structure to show different places for double bond in the molecule. T-hydrogen resonance is about distributing double bonds to Lewis structure, contributing. There are certain rules. You have the same number of valence electrons. Now answer the question. Which of the following symbol is used to denote the more than one representation of a structures or resonance structure? Which symbol is used? Double-sided arrow is D. Which of the following is the group of individual resonance structures that contribute to the resonance hybrid? There are three structures for carbon. Each resonance structure actually exists. No. This is a molecule. Our limitation of showing the structure. They don't exist, but the blending of all three is the real molecule. Each resonance structure is more stable than the resonance hybrid. They are almost equal. In going from one resonance structure to another, electron move from one location to another. So this looks like the correct answer. None of these. This is no, I said. Each resonance structure is, they are all equal. That's not true. In going from one resonance to another, electron move from one location to another. Really, electrons don't move from one place. They are distributed all around the structure. We only showing our way of understanding using arrows. What is the correct answer for this? A student attempt to draw several resonance structures for sulfur trioxide, because changing the number of valence electrons is not allowed. Changing the position of valence electron, that's allowed. Changing the number of protons and neutrons. We don't change nucleus. Changing the position of the atomic nuclei, that's not allowed. Only allowed is B. I'm sure about this. B is the correct answer. Okay? There are other questions about resonance. Which of the following is a false regarding the individual resonance structure that contribute to the resonance hybrid? Resonance structures of each resonance hybrid exist in the equilibrium with each other. That's not true. That's not an equilibrium. Real thing has different properties. Each resonance structure is less stable than if the resonance hybrid. Resonance structures of the resonance differ only in the position of valence electron. The position of nuclei is the same. False. False is atomic nuclei is the same. Resonance structures differ only in the position of. It looks like C. Each resonance structure is less stable than not necessary. A is the definite answer. It doesn't exist in the equilibrium. There's no equilibrium. The real thing is mixture of hybrid. Which of the following is true for carbonate ion? The carbon atom doesn't have octet. That's not true. The ion has 24 electrons. When you count electrons, it's added up to 24. The electron is constantly moving one double bond to another. That is not true. C is the true answer. B is the true answer. Iron has 24. It doesn't have octet. Carbon have octet. I already said it's false. The electron constantly moving, that's not true. Only true statement is B. I want to start on this idea for today. Now we go over covalent bond, naming, and we also talked about resonance. Now, covalent molecules, covalent compounds have shape. Molecules has, for example, water has a shape. So how do you get the shape of a covalent compound is the idea that we're going to go over. We use a model called valence shell electron pair repulsion theory. When you look at the valence shell of an atom, the last electrons are distributed around the atoms, making the Lewis structure. So therefore, these electrons will repel between each other and make the shape. For example, if you take the water molecule, there are two lone pairs in the Lewis structure. The 4 electron pairs repel each other in the central atom. Central atom makes the molecular shape. So it will be in a tetrahedron. Then therefore two hydrogen going to be angular because those lone pairs repel. This is the idea. Lone pair electron repulsion of electrons in the central atom make the shape of the molecule. Valence electron of atom may be involved in forming single, double bond and triple bond. Can be unchaired, lone pairs of electrons. All of them count similarly, whether it's a single bond, double bond, lone pairs. But double bond has more electrons than single bond. Therefore, it repels little further than single bond. Triple bond repel more than double bond or single bond. So all electron groups, single, double, triple bond, are considered one unit of repulsion. Because like charges repel each other, because the electrons are negative, various regions of the electron density around the atom spread so that it is as far away as possible from each other. Let's look at methane. Methane has this structure. How does 4 things arrange in space equally distant from each other? That's tetrahedral. Tetrahedral angle, perfect tetrahedral. How many of you heard about tetrahedral shape? Tetrahedral shape. There are shapes, angular shapes, stuff like tetrahedron is 4 corners, 4 edges. Angle is 109 because 4 things distributed in space form angle of 109. What is the angle between carbon, hydrogen, and methane? 109. Tetrahedral angle. That's the valence electron repulsion theory. Ammonia has this structure. What do you think the structure is? There's a 3 hydrogen, 1 lone pair, according to Lewis structure. The lone pair also, we don't see a structure there. Electron cloud repel other 3 hydrogens down. Therefore, it is less than 107. Do you see 107? 109 should be the right tetrahedral angle. Why ammonia is 107? The lone pair repels a little bit more. Therefore, this molecular shape is called triangular pyramidal, triangle base, and a pyramid, or pyramidal. Pyramidal is named for this shape, pyramidal or triangular pyramidal. This is less than 105. pyramidal, trigonal pyramidal. There are two names for ammonia. Water. Water has four electron pairs. Two bonding electron pairs, two non-bonding electron pairs. It's based on tetrahedral electron repulsion idea. But the two non-bonding electron pair, in ammonia you had only one. Therefore it pushed down 109 to 107. But in water there are two lone pairs of electrons. It repels bonding electron pairs further. It contracts from 109 to 104.5. So this is called angular. Ammonia molecule is called triangular pyramidal or pyramidal. This is called angular or bend. Bend or angular. Bend means like elbow. Why it is 104.5? Ammonia is 100.7, 107. Ammonia got only one lone pair. Water got two. It pushes down the 109 further. It's pretty easy to tell the angles between atoms in a covalent molecule. We already know the Lewis structure of this. This is the how many electron pairs are in here? 3. I told at the beginning, single, double, triple, and non-bonding have the same effect, except triple bond has more pushing than double bond or single bond. Lone pair has more pushing other electron than single bond. So this is 3 electron pairs, trigonal planar. This is trigonal planar. Whole molecule is planar. This is a planar molecule on the side. So ethylene is planar molecule. Ethylene is planar molecule. How about acetylene? Acetylene has 3 double bonds, but 1 triple bond. This is counted 1, this is counted 1. Therefore, linear. Two things equally away from each other is linear. It's a linear molecule. Side view, you can see like a dark. That's a linear. Acetylene is bond angle is 180. Ethylene is 120. This one is 120. Why this is little bigger than 120? Because this double bond pushes rest of it, these two further. Even you can explain minor variations. So tetrahedral angle, based on tetrahedral angle, methane gets tetrahedral structure, ammonia gets pyramidal or triangular pyramidal structure, water gets bend structure. Planar structure. Both formaldehyde and this is trigonal planar, this part, therefore planar molecule. Linear molecule, carbon dioxide, has 2 electron pairs, double bonds, two electron groups, therefore 180. If I ask you what is the bond angle between, what is the shape of water? Shape of water is angular or bent. Ammonia is pyramidal or triangular pyramidal. Methane is tetrahedral. Ethylene is planar, 120, close to 120. Acetylene and carbon dioxide is 180, linear molecule. The angle between this is 180. This is 120. This is tetrahedral. Ammonia is close to 107, water is 104 because the lone pairs changes the angle. Which of the following is classified as a group in the valence shell electron pair repulsion theory? An atom, we don't talk about atom repulsion, a lone pair of electrons and valence electron, either an atom or valence electron. Which of the following group is valence shell electron pair repulsion? A lone pair of electrons of atom. A valence electron, we don't talk about valence electron individually. One of the group is lone pairs. I didn't see the either an atom or lone pair. We look at the atoms also. I didn't understand the question. Atom also shape is related by valence shell electron pairs plus the atom. That's the angular geometry is associated with molecule which is central atom mass, 2 bonds, and angular geometry is associated with border. Border has 2 non-bonding, bonding, 2 bonding, 2 bonds, and first one, 2 bonds and 2 non-bonding electron pairs. That's the correct answer. More than that's also correct. 2 bonds and 1 non-bonding, that's not correct. 2 bonds and no bonding electron. Central atom has 2 bonds, bonding electron, bonds, and non-bonding electron. First one, 2 non-bonding, 1 non-bonding. 2 bonds and no non-bonding electron. Okay, I got it. If you have that's angle, if you have this lone pair and 2 bonds, this is also 2 bonds, 1 non-bond. That's also has angular shape. Therefore, answer is 2 bonds and 1 non-bonding. Because if you have a triangle, 1 becomes non-bonding, it becomes angular, right? Therefore, 2 correct answers. This is kind of tricky. I'm going through this because you have to show the complexity of stuff to understand that. What are the bond angles in tetrahedral geometry? You can answer this question. What is the tetrahedral geometry angle? Tetrahedron 109. Remember, methane has perfect tetrahedron 109. Is C. Valence shell electron pair repulsion VSEPR theory predicts that geometry of the is. Now, nitrogen is NH3. PH3 is same group, therefore same Lewis structure. Lewis structure of ammonia is trigonal pyramid or pyramidal. Therefore, pH3 should be same. Trigonal pyramidal or pyramidal is the C. We use periodic table to get the same Lewis structure are formed by same elements in the group. Which of the following molecules does the carbon atom have a nearly tetrahedral distribution in electron density? Which one? C2H6. C2H6 has structure. There are 4 bonds here. Therefore, it says tetrahedral. Acetylene and ethylene has double bond, triple bond, and a double bond. Therefore, they don't have tetrahedral. Answer is C. Which of the following molecule does the carbon atom has a nearly trigonal? Trigonal plane is B. Remember ethylene we talked about? I'm going to finish this after. Which of the following carbon atom has linear distribution? Linear means acetylene. So these gives different angles. Trigonal plane is 120, is C. Question 231. Linear distribution is 180. The answer is D. Ammonia is, what the angle in ammonia? 107, D. It's deviated from 109. Water molecule has 104, that's C. Predict the bond angles of the carbon atom in carbonic acid. 120. Carbonic acid has trigonal planar, 3 bonds in the carbon atom. So we are done with the predicting geometry and the angle. We're going to work on it. Okay, you guys been good. Do you have any questions or anything? All right. See you next Wednesday.